Let's do some exponent examples that involve division. Let's say I were to ask you what 5 to the 6th power divided by 5 to the 2nd power is. Well, we could just go to the basic definition of what an exponent represents and say, well, 5 to the 6th power, that's going to be 5 times 5 times 5 times 5 times 5, one more 5, times 5. 5 times itself 6 times. When 5 squared, that's just 5 times itself 2 times. So it's going to be 5 times 5. Well, we know how to simplify a fraction or a rational expression like this. We can divide the numerator and the denominator by 1 5, and then these will cancel out. And then we can do it by another 5, or this 5 and this 5 will cancel out. And what are we going to be left with? 5 times 5 times 5 times 5 over, well, you could say over 1. Or you could say that this is just 5 to the 4th power. Now notice what happens. Essentially, we started with 6 in the numerator, 6 5s multiplied by themselves in the numerator, and then we subtracted out. We were able to cancel out the 2 in the denominator. So this really was equal to 5 to the 6th power minus 2. So we were able to subtract the exponent in the denominator from the exponent in the numerator. And let's remember how this relates to multiplication. If I had 5 to the, let me do this in different colors, 5 to the 6th times 5 to the 2nd power, we saw in the last video that this is equal to 5 to the 6 plus, I'm trying to make it color-coded for you, 6 plus 2 power. Now we see a new property. And in the next video, we're going to see that these aren't really different properties, that they're kind of same sides of the same coin when we learn about negative exponents. But now in this video, we just saw that 5 to the 6th power divided by 5 to the 2nd power, 5 to the, let me do it in a different color, 5 to the 2nd power is going to be equal to 5 to the, it's time consuming to make it color coded for you, 6 minus 2 power. 6 minus 2 power, or 5 to the 4th power. Here it would be 5 to the 8th. So when you multiply exponents with the same base, you add the exponents. When you divide with the same base, you subtract the numerator exponent, you subtract the denominator exponent from the numerator exponent. Let's do a bunch more of these examples right here. Let's do a bunch more. What is 6 to the 7th power divided by 6 to the 3rd power? Well, once again, we can just use this property. This is going to be 6 to the 7 minus 3 power, which is equal to 6 to the 4th power. And you could multiply it out this way, like we did in the first problem, and verify that it indeed will be 6 to the 4th power. Now let's try something interesting. Let's try something interesting. And this will be a good segue into the next video. Let's say we have 3 to the 4th power divided by 3 to the 10th power. Well, if we just go from basic principles, this would be 3 times 3 times 3 times 3. All of that over 3 times 3. We're going to have 10 of these. 3 times 3 times 3 times 3 times 3 times 3. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, if we do what we did in the last video, this 3 cancels with that 3. Those 3's cancel. Those 3's cancel. Those 3's cancel. And we're left with 1 over 1, 2, 3, 4, 5, 6 3's. So 1 over 3 to the 6th power, right? We have 1 over all of these 3's down here. But that property that I just told you would have told you that, look, this should also be equal to 3 to the 4 minus 10 power. Well, what's 4 minus 10? We're going to get a negative number. This is 3 to the negative 6th power. So using the property we just saw, you'd get 3 to the negative 6th power. Just multiplying them out, you get 1 over 3 to the 6th power. And the fun part about all of this is these are the same quantity. So now you're learning a little bit about what it means to take a negative exponent. 3 to the negative 6th power is equal to 1 over 3 to the 6th power. And I'm going to do many, many more examples of this in the next video. But if you take anything to the negative power, so a to the negative b power is equal to 1 over a to the b. That's one thing that we just established just now. And earlier in this video, we saw that if I have a to the b over a to the c, that this is equal to a to the b minus c. That's the other property we've been using. Now, using what we've just learned and what we learned in the last video, let's do some more complicated problems. Let's do some more complicated problems. Let's say I have a to the third, b to the fourth power over a squared b, and all of that to the third power. Well, we can use the property we just learned to simplify the inside. This is going to be equal to a to the third divided by a squared. That's a to the 3 minus 2 power, right? So this would simplify to just an a. And you can imagine this is a times a times a divided by a times a. You'll just have an a on top. And then the b to the fourth divided by b, well, that's just going to be b to the third. Right? This is b to the first power. 4 minus 1 is 3. And then all of that in parentheses to the third power. I don't want to forget about this third power out here. This third power is this one. Let me color code it. That third power is that one right there. And then this a in orange is that a right there. And I think we understand what maps to what. And now we can use the property that when I multiply something and take it to the third power, that's equivalent of taking each of these. This is equal to a to the third power times b to the third to the third power. And then this is going to be equal to, this is equal to a to the third power. I'll do it like this. A to the third power. That's just a to the third right there. And then what is this? Times b to the 3 times 3 power, times b to the ninth. And we would have simplified this about as far as you can go. Let's do one more of these, because I think they're good practice and super valuable experience, I think, later on. Let's say I have 25 x y to the sixth over 20 y to the fifth, y to the fifth x squared. So once again, we can rearrange the numerators and the denominators. So this you could rewrite as 25 over 20 times x over x squared. Right? We could have made this bottom 20 x squared y to the fifth. It doesn't matter the order we do it in. Times y to the sixth over y to the fifth. And let's use our newly learned exponent properties and actually just simplifying fractions. 25 over 20, if you divide them both by 5, you're going to get this is equal to 5 over 4. X divided by x squared. Well, there's two ways you could think about it. That you could view as x to the negative 1. You know, you have a first power here. 1 minus 2 is negative 1. So this right here is equal to x to the negative 1 power. Or it could also be equal to 1 over x. These are equivalent. So let's say that this is equivalent to 1 over x. Just like that. And it would be x over x times x. One of those sets of x's would cancel out, and you're just left with 1 over x. And then finally, y to the sixth over y to the fifth. That's y. That right there is y to the 6 minus 5 power, which is just y to the first power, or just y. So times y. So if you want to write it all out as just one combined rational expression, you have 5 times 1 times y, which would be 5y. All of that over 4 times x. Right? This is y over 1. So 4 times x times 1. All of that over 4x. And we have successfully simplified it.